Today we will be starting a new learning target, 8C, Exponential Growth and Decay. So get your Cornell notes set up and ready to go. First, we are going to review exponential functions. So looking at our general form of the equation, y equals a times bx, we have a as our initial value, and we have b as, in this situation, it is going to be our growth or decay rate. Before, we called it our common ratio. So this should look pretty similar from geometric sequences, so hopefully you're familiar with this. Some key terms to know are growth and decay. So growth is when your graph is going to be increasing and the base value is greater than 0. So notice the inequality, b is greater than 0. Decay is when your graph is going to be decreasing and the base value is less than 0. So notice this inequality, the b value is less than 0. One thing to note is that when we are dealing with story problems, we are going to be converting percentage rates into decimals so that we can add or subtract them to our b values, or to make our b values. So how you do that is by dividing your decimal or your percent by 100 to get a decimal. And that decimal number is what you'll be adding or subtracting to 1 to get your b value. And you will see examples of this coming up. First, we're going to look at exponential growth. When looking at growth, we have our general formula, which is y equals a times bx, just like it is all the time. Our initial value is a. Our b value is the base, or the growth factor in this situation, which is also called the common ratio. And then we have a is greater than 0 and b is greater than 0. So, to get your b value, as I mentioned before, we are going to do 1 plus the rate, because it is growing, so it is going to be adding the rate to 1. And then x is going to represent time in most cases. Let's look at an example. Movie tickets now cost $9.75 a ticket, but they are increasing at a rate of 15% per year. Write the equation and find the cost for a ticket after 3 years. So we are going to start with our general form of the exponential equation, which is y equals a times bx. Then we're going to look to our story problem to get the rest of our information. So our a value, that is our initial value, and in this situation it is going to be $9.75 because right now tickets cost $9.75 a ticket. So we are going to fill in $9.75 for our a value. Our b value is going to be our growth rate because we are looking at a growth example and it says increasing. So that is how we know that it is growing. It is increasing, and it is increasing at a rate of 15%. So to get the decimal that we need, we can go to our calculator, turn it on, maybe. There we go. We are going to go 15 divided by 100, and that's going to give us our decimal, so 0.15, and we are going to add that to 1. So 1.15, that is our b value. Okay, and now to write our general form, or to write our matching equation for this story problem, we are going to fill in the general form of the equation with our new values. So a value is $9.75, and then we're going to go times b, so times 1.15, and then x always is attached to your b value, or your growth or decay rate. So x goes by the 1.15. So that is our equation that matches our story problem. Now we are going to look at how much a movie ticket will cost in 3 years. So there are 2 ways that you can do that. You can enter it into your y equals. So as we see, we have 975 times 1.15 to the x. So don't forget the little caret button, which is on the right side of your calculator. That is how you raise an exponent. All right? So you can put it into your y equals, and then you can look at the table. So if we go to the table, we can see that when x is equal to 3, y equals 14.82. So really 14.83. So let's write that down. We got 14.83 when doing it from the table. There's another way to do it, which is simply by putting in a 3 wherever you see an x in your equation. So if we rewrite our equation, we have 975. Let's move this up a little bit. We have 975 times 1.15. And then instead of writing x, we're going to write a 3. And then we are going to enter this into our calculator to see what we get. So 975 times, and I'm going to put it in parentheses just to be safe, 1.15 raised to the 3rd power. What do you get? 14.828. So 14.83 again, which is exactly what we were looking for. All right, so those are the 2 ways that you can answer a specific question that is talking about future years or future whatever x value it wants you to find. These are 2 different ways that you can do it. So now we will look at exponential decay. The general formula for this, again, is y equals a times bx. Our initial value is a. B is our base, our decay factor, or our common ratio. So when looking at decay situations, your a value will be greater than 0, and your b value will be less than 0. So make sure you're paying attention to that, because when coming up with your b value, you're going to be going 1, subtract the rate. When it is a decay situation, you're subtracting the rate from 1. And then x will represent time in most situations, like we said before. So let's look at an example. A computer is purchased for $2,000, but is losing value at a rate of 20% per year. Write the equation, and we're not going to graph the situation, but we are going to answer the question, what will the computer cost after 4 years? So we start out with our general general equation, so a times bx, and we're going to look for a, our initial value. Well, when I look at this, I see that the computer is purchased for $2,000. So that is telling me initially the computer was $2,000, so that is what I'm going to write for my a value. My b value, my growth or decay rate. Well, I see that the computer is losing value at a rate of 20% per year. So because it is losing value, it is decreasing. Therefore, I know it is a decay story problem. So 20%, let's put this in our calculator. If we go 20 divided by 100, it equals 0.2. And if we do 1 subtract 0.2, because it is a decay example, so we need to subtract our rate, we get 0.8. So our b value is going to be 0.8. So when we rewrite our equation with our new values, we are going to have 2,000 times 0.8 to the x. Okay? And then we can answer the question, how much will the computer cost after 4 years, since we now have our equation that matches our story. So let's go to our table. Actually, let's go to our y equals and enter our new equation in here so that we can look at our table. So 2,000 times 0.8. And then you have to raise it to the x power. Don't forget that. Use your little caret key. And we want to look at the table. And we want to know how much the computer will cost after 4 years. So that means when x is equal to 4. That's what this is meaning. So I will make a little note right there for you. So we're going to go down to where x equals 4. Whoops, there it is. And go over. And it says 819.2. So the computer will cost $819.2, so really that's 20 cents after 4 years. So that's how much value it lost. Okay? So now we are going to do some practice. So for each one of these situations, I would like you to do what we just did in our previous examples. So write the equation and then answer the question for each one. So the first situation is the number of bacteria in a colony is 180 at 12 p.m. and the bacteria grows at a rate of 22% per hour. How many will be present at 8 p.m.? So make sure you write the equation that matches that situation, and then answer that question. The second situation, a house was purchased for $226,000 and has lost 4% of its value each year for the past 5 years. So what is it worth now? So make sure when you're doing this, it is helpful to underline some key information, just like I did in those examples. So I would go through and underline any important information and then try to write your equation and answer the question. Okay? So take a few minutes to do that and be sure to pause the video because the answers will be on the next slide. So here are the answers for each question. Our first one, we have our general equation. Then we have our a value of 180, our b value of 1.22. We have our general equation, 180 times 1.22 to the x. And then right here, I didn't show you the table. I showed you what it would look like if I entered in 8 for x right here. And then the answer would be 844 bacteria at 8 p.m. For our decay example, you have your general equation. Your a value is 226,000. B value is 0.96. Your general equation is going to be your equation that matches your story will be 226,000 times 0.96 to the x. And then again, I showed you what it would look like if you entered in it into your equation. And the answer you would get is $184,274.23. Okay? If you have any questions, be sure to ask Mr. Braychuk, Mr. Dunn, or myself. Have a great day, guys.